All right, so I want to go over a few terms that you need to be familiar with in order to properly design and discuss your experiments. All right, so first off, hypotheses and predictions. This can often be confusing for students, so let's just clarify. A hypothesis is a refutable statement to help explain that explains a phenomena. Okay, so let's say that I'm a scientist and I have a drug that induces rapid growth in cells. So I might have a hypothesis that drug X that induces rapid growth in cells can be used to speed up hair growth in patients. Okay, experiments can support or disprove a hypothesis, but they can never prove a hypothesis true. All right, that's important to understand. All right, now what about predictions? Well, predictions are what you expect for experimental results, assuming your hypothesis is true. Okay, so for this example, I could have a prediction that I would find increased rate of hair growth in patients given my drug X. All right, so it's specific to your experimental setup, what you think you will find. All right, now in designing your experiment, there are some variables that you want to consider. So independent, dependent, and controlled variables are important to consider when designing your experiment. So your independent variable is what you are testing in your experiments to see if it has an effect on the outcome of that experiment, right? So in the example that we've been talking about, my drug treatment would be my independent variable, right? So do you get the drug, a different drug, no treatment, etc.? That's my independent variable. The dependent variable is a quantifiable outcome that you're measuring in your experiment. So in this case, rate of hair growth, right? And it has to be quantifiable, right? Rate is something very quantifiable. Pretty hair in and of itself is not quantifiable, right? You would have to qualify that pretty hair as defined by judges who rate prettiness of hair on a scale from 1 to 7, something like that. Turn it into something quantifiable, into numbers. All right, and then you also have controlled variables in your experiments. The purpose of controlled variables are to basically control or remove all other possible variation within the experiment. So in our example here, so how long you wait between doing the treatment and measuring rate of hair growth, right, would be important. How much did the hair grow in 2 weeks? I don't want to use 2 weeks and see how much somebody's hair grew in that time and 1 month for somebody else. I want to keep that as a controlled variable, the same throughout the experiment. How I apply the treatment can also be important. How I measure the hair also can be important, right? My hair is pretty curly. Are you measuring it from here to here, or are you going to pull it straight and then measure its length? These are all things to consider to make sure that your experiment is as uniform as possible. All right, now also important for experiments are positive and negative controls. And you basically use these to ensure that your assay is capable of giving both positive and negative results, right? So to ensure that your assay is working properly as you believe it should. So in our example, a positive control could be something that I am positive, that I know will increase rate of hair growth. So maybe I'm going to have people take Rogaine, I don't know. And use that as a positive control so that I can ensure that I can measure increased rate of hair growth. A negative control could be no treatment or some form of placebo treatment, right, to make sure that I get a good baseline of what no increase in hair growth looks like. I need both of these in order to compare my experimental group and see, well, do they have increased rate of hair growth? All right, let's go through another example. So let's say that now I'm interested in bees, and I have a hypothesis that bees see certain wavelengths better than others, and I believe that they will be most attracted to colors in the middle of this spectrum, such as red. Okay, so there's my hypothesis. Bees are most attracted to colors that have a wavelength in the middle of their visual spectrum. All right, my prediction then might be that bees will be, given the choice, bees will more often choose red flowers over other colors of flower, right? Now, what would I have as my independent, dependent, and controlled variables? So my independent variable would be flower colors, right? Which colors of flower are they given the choice between? Dependent variable would be, let's say, which flower they choose. And remember, it has to be quantifiable, so I can define that in different ways. So perhaps I'm going to wait 5 minutes and count how many bees are within 1 foot of the red flower versus how many bees are within 1 foot of the other flower. Okay. Controlled variables would be distance between the bees and the flowers, right? I want to keep, if I have flower over here and a flower over here that they're choosing between, I want the bee to be placed exactly in the middle, right? Keep that distance constant so it doesn't come into play. Type of flower, right? So maybe I want to just use white flowers and then dye them red, dye them yellow for my experiment. So the smell, the shape, the size, etc. of the flowers are as uniform as possible. All right, what do I use for positive and negative controls in this example? Well, my positive result of my assay would be a strong preference for this flower over this flower, right? So in this, perhaps I put a flower here and no flower here. And I very much expect that if my assay works properly, I should be able to see lots of bees come over to this flower, right? There's nothing over here, they should not be interested in that. So this will just ensure that my choice of dependent variable, how I'm measuring it, etc., are proper. A good negative control might be having a red flower and a red flower. I don't expect that there's anything for the bees to prefer for this flower over that flower, so they should be, randomly or equally distributed. So that should give me a negative result where we do not see a strong preference of the bees, right? And then my experimental group would be red flower versus, say, yellow flower, something like that. All right, so these sound simple, but in practice they can be quite complicated. So don't hesitate to talk about this with your lab group, your lab instructor, me, etc., and just practice all the terminology as you're doing your experimental designs throughout the semester.